This is CPM Precalculus, Chapter 2, number 44. So here we're asked to rewrite each expression of the following radical expressions using fractional exponents instead of radicals and exponents. So basically we want to go from radicals, right, that's the roots, to fractional exponents instead. We want to be something to a fraction, right, like a over b. Okay, so what you need to know is here for part A, remember that the cube root here is the same thing as what's inside to the power of 1/3, right? The cube root means 1/3, and that means right here, to simplify this, we multiply 2 times 1/3, so we have 5 to the power of 2 times 1/3. To multiply 2 and 1/3, remember 2 is over 1, and that's equal to 5 to the power of 2 times 1 is 2, over 3 times 1 is 3, right? So this, we have 5 here, and up in the exponent we have 2/3, all right? So let's go on to B. B, we're asked the fourth root of 2 to the power of 5. Okay, so let's go ahead. So again, we're not asked to evaluate, so once we get to the fractional exponent, we're done. Alright, so let's go ahead and evaluate this. Remember again, the fourth root here, that just means whatever's inside that root to the 1/4 power, right? And again, we have that all to the power of 5. Okay? So simplifying this using the properties of exponents, that's the same as 2 to the power of 1/4 times 5. And that's the same as 5 over 1. So we multiply the numerator and denominator, so that's just 2 to the power of 5 over 4. Okay? Box your answer. Let's go on. Part C asks us, what is this root, or the square root, right? If there's nothing there, it means 2, square root of 7 cubed, right? So like I just said, when you're figuring this one out, if there's nothing here, it's an implicit, invisible 2 right there. So that means we're going to take what's inside, right, and take it to the power of 1/2. Because basically we put 2 in the denominator, 1 in the numerator of the power. Okay, so that's the same thing as 7. 3 times 1/2, well, 3 over 1. So that's going to be 3 times 1 and 1 times 2. And that gives us 7 to the power of 3/2. Okay? Let's get part D. Okay, D says square root of 7 cubed. Okay, so to simplify this, what do we do first? Well, remember the square root has an implicit 2 there, so that means it's 7 to the power of 1/2 inside these parentheses, which are raised to the power of 3. And this means we multiply 1/2 and 3, and remember 3 is over 1, so that's just equal to 7 to the power of 3 over 2. Okay, so that's the same thing written from radical form to fractional exponent form. Alright, part E, we are given 7 times square root of 7. Okay, so how do we simplify this? Well, we know 7 is just 7, and square root of 7 is 7 to the power of 1/2. Okay, so what do we do now? Well, here you have to remember 7 without a power here, right? There's no power here. Well, there's an implicit 1 there, right? So we're having 7 to the power of 1 times 7 to the power of 1/2. And when we have the same base and different exponents, we don't multiply, but we add those exponents, right? So we're adding 1 plus 1/2, right, to the same common base. So then what's 1 plus 1/2? Well, we know 1 plus 1/2, what's the common denominator, right? Well, so far, 1 is over 1, right? So finding a common denominator, it's going to be 2. So we multiply this by 2 over 2, and we get That's equal to 2 over 2 plus 1 over 2. Now we can add the numerators and we get 3 over 2. So this was just a bubble work, so let me put it in a bubble so it doesn't get confused with what we're doing. And that's equal to 7 to the power of 3 over 2. And we did that work right there. Okay? Finally, part F. Part F is asking, what is 9 times the cube root of 3? Okay? So this is similar to the one we just did. We know 9 has an implicit, invisible 1 as the exponent. So that's 9 to the power of 1 times 3. The cube root is to the 1/3, right? So how do we get these to have the same base? Because this one's 9 and this one's 3. Well, you have to know that 9 is the same as 3 squared, right? So this is same as 3 squared, right? 3 squared, and we have to the 1 power, right? Because I'm copying it from there, times 3 to the power of 1/3. So let me simplify this first, and that's the same as 3 squared, because 2 times 1 is 3, times 3 to the 1/3 power, right? And now we have the same base. We're multiplying two numbers with the same base and different exponents. That means we take the same base and add the exponents. Okay, so again, let me do this addition in a bubble. So it's 2 plus 1/3. Remember, that's 2 over 1. So what's the common denominator? Well, between 1 and 3, it's 3. So multiply this by 3 over 3, and you get 6 over 3 plus 1 over 3. Now you can add the numerator, that's 7 over 3. So then this is in our bubble here, right? And we can say this then is equal to 3 to the power of, and we just figured it out, 7 over 3. All right? So that is part F. All right. So this was converting between radical expressions into fractional exponents. All right? Fractional exponents. And that ends CPM Precalculus Chapter 2, number 44.